All right, ladies and gentlemen, we are here for another riveting edition of How the Heck Do You Do My Math? You will notice I have some pre-scribbles on here because I started making this video and my neighbor Jim came over and rang the doorbell. So we're starting over. This is 13.2 day 4. We're going to learn about arc length, area of a sector. Pretty straightforward because they are formulas and we are really good at formulas, so that's going to be helpful. A sector is a portion of a circle. It's like a slice. It's created by two radii, fancy term for radiuses. And when you have a sector, you can kind of look at two elements. You can either have the radius here and here, and then it goes a certain angle, and then you can either measure the distance along the outside of this from here to here linearly, meaning in feet or inches, whatever units the radius is measured in. This is called arc length because it's an arc and you're trying to find out how long it is, therefore arc length. But the part that doesn't make sense is that it's represented with an S, which is not my doing, so it is what it is. To calculate arc length, it depends on how long the radius is, because obviously if it was only to here, it would be a lot shorter arc. And so it's how long the radius is and also how far open is this angle. Is it a really skinny angle, a really wide angle? Those two things affect the length. So the formula is exactly that. The arc length will equal the radius times the central angle, meaning this angle in the center created by the center of this circle. The catch is that this angle must be in degrees. That's not what I meant. It must be in radians. Oops. And so that is the reason that we waited until now to utilize this formula, because we didn't know how to find radians if we had degrees. So we might have to do convert. So we might have to convert if needed. Alrighty, so the other thing that we're going to be practicing measuring is the space that's inside that sector, called the area of the sector, for obvious reasons. Here's your formula. Again, it's reliant on the radius and the angle, and again, it's still true that that angle has to be in radians. And so the only thing that will make using this formula tricky is if you have a degree measure. You have to notice that and then pay attention to do your conversion before you start utilizing that formula. So, alrighty. So we just have two examples and then that is a wrap. Find the arc length and area of the sector whose central angle is 5 pi 14ths. Well, 5 pi 14ths is in radians. The radius is 7. And since the radius is in feet, keep in mind that will be our units. One thing to keep kind of in your head is that arc length will be measured in plane units and sector area will be measured in units squared, because this is just measuring the distance along the circle's edge and this is measuring the actual area inside. So I already know that my arc length will be in feet and my sector area will be in feet squared. So arc length, S equals R times theta. In this case, R is 7 and my theta is 5 pi 14ths. And so in this case, I don't have to convert it because it's already in radians for that formula. So I'm going to have 7 times 5 pi. So in terms of an exact answer, I'd have 35 pi 14ths. I'm having speaking troubles. That would be 35 pi 14ths feet. Now that's the exact value because it doesn't round off, but you can't really be like, hi, I need a piece of wire that's 35 pi 14ths feet long. Nobody's going to have a clue what you're talking about. So you would take 35 times pi, and then you would divide that by 14, landing you at, does it tell me what to round off to? No, 7.85. So it would be 7.85 feet because it's linear, so it's not going to be squared, and it's using the same units as the radius would. When I go to do sector area, I just write down my formula, 1/2 r squared theta, and again, that's for radians, which I have, so I would have 1/2 7 squared times my 5 pi over 14. So I can type this whole thing straight into my calculator. I can have 1/2, times 7 squared, and then times 5 pi divided by 14. And so this one gives me an area of about 27.5. And then since it's area, it would be feet squared. So pretty straightforward. This last one is still pretty straightforward. The only catch is going to be that my theta is 120 degrees. I need it in radians. My radius is 18 feet. So I'm going to start with S equals R times theta. I know this is going to be 18, but I need to take my 120 and convert it into radians like we learned how to do on day 2. So I'm going to take 120 degrees and use my conversion factor in a way that will eliminate the degrees and leave me with radians. So I end up with 120 over 180, which reduces to 2/3. So in the end, my theta is 2 pi thirds in radians. And that's going to be usable in both formulas, so I don't have to do that work twice. I'll put my 2 pi thirds in here. And for 1/2 r squared theta, I knew my 18, but now I'll put my 2 pi thirds in here as well. So that's the only thing that's different, is having to do that conversion before plugging it in. And now it's just back to my calculator. And again here, I wouldn't probably multiply this out and call it 36 pi thirds, which would turn into 12 pi. I would probably go ahead and find out what is that as a decimal, unless I was told I had to do exact answers. So I have 18 times 2 times pi on the top, and then divided by 3. So the arc length is 37.7, and this was measured in feet as well, because it always matches the units from the radius. And over here, I would have my 1/2 times 18 squared, so remember to square that one in this formula, times 2, and then pi, and divided by 3. So this one is giving me an area of 339.3, and because it's area, I'm going to have feet squared. So this last day is just a few formulas. The worksheet's just going to have you go through and practice those formulas. And the main thing to keep in mind is that if you don't have radians, you need to convert before you begin. So it should hopefully go quick and easily. And that's the end of your week. Make sure you send me a picture of your work from that worksheet, and then you can call it a week. Have a great weekend, you guys. Bye.